Okay, so next up, we have a few examples. Before we get into these examples, I'm just going to kind of reiterate the fact that when we're looking for solutions to trig equations, depending on the context of the question, we can have one solution, we can have two solutions, we can have an infinite set of solutions. So it's real important. Right now, the last example I just gave you, it wasn't set, so we had to identify all possible solutions, and that's why we brought in that integer value of n. So just to kind of reiterate, if we're working in degrees, our first angle that we identified for theta was 90, and then every rotation, full rotation from 90 was 360 degrees. So I can express that as all possible angles, 90 degrees plus 360n. If we were working in radians, 90 degrees in radians is pi over 2 here. And every full rotation from pi over 2 is 2 pi n. And that would express all possible solutions to that equation in radian measure. And again, that equation was sine of theta is equal to 1. And that was the last video that you just watched. So just a quick couple examples here. Solve for cosine theta, right? So remember, cosine theta is equal to the x-coordinate. Right, so I'm going to go around the circle and look, you know, at what points on the circle does the x-coordinate equal 1? So here's 1, right? And as I continue to go around my circle, I don't have any x-coordinates that are equal to 1 other than the first one we identified. So then I can turn around and say, well, then that would be this angle right here, right? Which is an angle of 0 degrees. So theta equals 0 degrees. Some might not identify it as 0, some might actually identify it initially as a 360 degree angle, and that's fine too if you identify it as 360 degrees, but remember, every full rotation we go around the circle, there's another coterminal angle that satisfies that equation, right? So we could go around the circle 1, 2 times, right? So now first we have 0 degrees, then we had 360 degrees, now we have 720, and we can generalize this by just using that generalized expression. So we can then summarize and say theta is equal to 0 degrees plus 360 degrees times n, or simply just theta is equal to 360 degrees times n here. Okay, so either one of these two bottom work. The last one is the preferred one because it's just a little bit simpler. Part B, sine of theta equals -1. Again, remember that the sine of an angle measure is equal to the y-coordinate of the point. So sine of theta is your y-coordinate. So I'm going to move around the circle again from standard position and try to identify all the y-coordinates that are equal to -1. And that would be this point right here. Okay, so this is the point 0, -1. This angle right here is a 270 degree angle, right? And every full rotation from that 270 degree angle will bring us back to another y-coordinate of 1 here. So we can now summarize and say theta is equal to 270 degrees plus 360 degrees times n. The next two examples I'm going to hit part D first, because part C is just a little more complicated. Cosine of theta equals 0. Again, remember that the x-coordinate is equal to the cosine of theta. So I want to move around the circle and identify all angles where the x-coordinate is 0. Right? So I'm going to go standard position, rotate counterclockwise. So I have a coordinate right here at 0, 1. That's one angle. I'm going to continue to go around the circle. It's an x-coordinate of -1. Continue around the circle. I have another point here now. So this point is the point 0, -1. Right? So both of these 2 points have x-coordinates of 0. And then, you know, finish my circle, and those are the only 2. So I have one angle right here. That's a 90 degree angle. Also, I have another angle down here. That is a 270-degree angle, right? So just speaking about the 90-degree green angle right now, every full rotation from 90 degrees brings me back to another coterminal angle, which satisfies this equation. So we could turn around and say this. We could say theta is equal to 90 degrees plus 360 degrees times n for the green angle. For the red angle, I can say 270 degrees plus 360 degrees times n. However, if you really focus in on this and think about it, every full rotation, every half rotation of 180 degrees that you travel from the first green angle that we identified to the red, that's a 180 degree rotation right there, right? And every 180 degree rotation from the red angle takes me back to the green angle, right? So we can actually summarize these two answers right now and bring it into just theta is equal to 90 degrees plus 180 degrees times n. This would be the better way to express that answer. Every 180 degree half rotation from 90 degrees takes us back to either the initial 90 degree angle we identified or the 270 degree angle we identified. And lastly, we're looking at cosine theta equals root 2 over 2. Again, reminding you that x equals the cosine of the angle. So now we're looking at, where on the x-axis, right? Where on the x-axis does my x coordinate equal root 2 over 2? So if you remember that root 2 over 2 should hint at a 45 degree angle, if you think about it. So I have a 45 degree angle right here, right? And you can kind of verify it with your 45, 45, 90 degree triangle, where both the x and the y coordinates are congruent here, right? So this is really a coordinate point of root 2 over 2, comma, root 2 over 2. However, there is also another angle in the fourth quadrant down here. It's a multiple of 45 degrees, right? That also has an x coordinate of root 2 over 2, comma, root 2 over 2 here, right? So this is where it's getting a little more complicated. And got to understand that really what we're focused on is just the x coordinate of the point and the angle that corresponds to it. So for my green angle, it's pretty clear that we identified a 45 degree angle. And then for my blue angle, if I rotate from standard position all the way to that angle right there, that's going to bring me to, oops, excuse me, okay, so that's going to bring me to a 315 degree angle here. Right. Now, just to point out here that this point on the x-axis right here is this, is that root 2 over 2. And if you look down, right, in the first and in the fourth quadrant, we actually have two coordinate points that share the same exact x coordinate there. So that's key. You want to kind of keep that in mind as you do more of these. And now we generalize, right? So for my 45 degree angle, I can turn around and say theta is equal to 45 degrees plus 360 degrees times n. So that's saying every full rotation of 360 degrees from that initial 45 degree takes me to a coterminal angle. And then for the blue angle, same thing. I can say theta is equal to 315 degrees plus another full rotation of 360 degrees times n here. There isn't really a simple way to kind of condense these two solution sets here, the way we did on the question part D for that one. So in some cases, you can condense both your solution sets into one, and then in other cases, you just have to identify both of them.